In number 3, we have a different sort of function. This is a rational function. So I took the liberty of graphing this one in Desmos, and this is what the graph looks like. There is no overlap. It passes both the vertical and horizontal line tests. Vertically, it gets closer and closer and closer to 2, but never actually touches it. Horizontally, it gets closer and closer and closer to 1, but never actually touches it. Therefore, it does pass the horizontal and vertical line tests, which means we do not have to restrict the domain. So since this is a one-to-one function, we want to find the inverse. So let's go ahead and do that. The key with rational functions when finding the inverse after you switch out the variables is to get rid of the denominator. Multiply both sides by the denominator. Then distribute the x. Then we want to get everything attached to a y on one side, everything not attached to a y on the other side. So I'm going to add 2x to both sides and subtract y from both sides. Now I can factor out the y. That is the key here. After you've factored out that y, we can isolate it by dividing both sides by x minus 1. And we will rewrite this using inverse function notation. And I will provide a picture of the graph that I input into Desmos earlier on today. Here is that graph. And it looks really similar to the first graph, but they are inverses of each other if you flip them over the x equals y line. So now we're going to find the domain of f. And we had already done that because we wanted to see if there was going to be a restricted domain. There does not have to be a restricted domain on this one. So the domain is from negative infinity to infinity, right? It passed the horizontal and vertical line test. That's not necessarily true because this was a rational function. And I'll just rewrite it down here. Just because it passes the vertical and horizontal line tests doesn't mean that this can have any input that we want it to. X cannot equal 2, so the domain is going to be from negative infinity to 2 union 2 to infinity. And we can see that, right? If we go across, if I scroll up to the previous graph, when we go across, there's one value that is not covered on the graph, and that is x equals 2. That is because x cannot equal 2 in this function. So what else can we fill in? We can fill in the range of the inverse. That will be from negative infinity to 2 union 2 to infinity. How about the domain of the inverse? There is one number that it cannot equal, and that number is 1. And now we can fill in the range of the original function.